are used to increase settling performance within a sedimentation basin. Tube settlers consist of inclined plates or channels that provide a settling surface area for particles in wastewater and drinking water. The total settling area is the sum of the projected area in horizontal direction multiplied with the total amount of plates or channels. To explain how tube settlers are designed, let's take a look at the following example. A drinking water plant has monthly maximum flow of 1 mgd or 3,785 cubic meters per day. The amount of total suspended solids entering the plant is 200 milligrams per litre, and the effluent permit requires 30 milligrams per litre. At first, we have to determine the settling velocity of the particles. The settling velocity of the particles very much depends on their size and shape. In general, smaller particles settle slower, hence they have a lower settling velocity. Particles which are smaller than 25 micrometer can usually not be settled down at all because drag forces, turbulences, rising particles and others within the sedimentation basin are bigger than the particle settling force. Also, spherical-shaped particles settle better than flat-shaped particles as their form offers less contact area for drag forces. Stokes' law is a good basis to calculate the settling velocity of particles. The formula versus settling velocity of the particle has to be bigger as all drag forces. Calculates the drag force depending on the density delta of the fluid and the particle, the size and form of the particle, as well as the lamellar flow in the tank. In our example, we have mostly sand and gravel that needs to be removed. The minimum particle size is 50 micrometer, and the density delta between the water and the particles shall be 12.5 pounds per cubic feet, or 200 kilograms per cubic meter. Sand and gravel have a rounded shape, therefore we will use a form factor of 0.8. The resulting settling velocity has to be bigger as 1.67 meters per hour, or 5.49 feet per hour. As Stokes' law assumes lamellar flow, no other colliding particles and other factors, but we want to design a sedimentation tank, we have to consider an additional safety factor. Depending on the retention time and water turbidity, different safety factors can be applied, but we'll just use a safety factor of 2. Therefore, the resulting settling velocity of the particles is 1.67 meters per hour divided by 2 equals 0.835 meters per hour, or 2.75 feet per hour. Knowing the settling velocity, we can now determine the total required amount of tube settlers. AET LLC offers different types of tube settlers, but for drinking water applications, the LS50 design is usually used. This tube settler type has a channel distance of about 1.75 inches or 45 millimeters and a projected surface area of 3.3 to 3.5 square feet per cubic feet, 11 to 11.5 square meter per cubic meter. Now, to determine the total required amount of tube settlers, the settling velocity of the particles has to be bigger as the total projected surface area of the tube settlers divided by the water flow. Solving the equation to x results in a total required projected surface area of 2,046 square feet, or 189 square meters. Dividing this result by 3.3 square feet per cubic feet equals the total required amount of 623 cubic feet, or 17.2 cubic meters of tube settlers for this application.